I can see some familiar names out there. Hello, everybody.
Okay, so it's 2 o'clock, so let me maybe introduce. We are very pleased to have a presentation by Ryan Hawthorne today. He has been PhD student at the University of Cape Town and graduated last year, and this paper is part of his thesis. He's also affiliated with University of Johannesburg and Director at Acacia Economics. As usual, there will be 45 minutes for presentations and then questions and answers, but you can also ask questions during the presentation. You're fine with this, Ryan, right?
Yeah, sure.
So please go ahead, the floor is yours.
Okay, great. Thank you. Thanks, Łukasz. Right, so this is a joint paper that I wrote with Łukasz Grabowski. And as Łukasz was saying, this was part of my PhD, and it's about narrowing the digital divide. So just by way of motivation, mobile broadband, as you know, is the main means of connecting people in developing countries. And so governments typically focus in developing countries on mobile broadband. So there might be a whole range of interventions like open access rules. In South Africa, we're considering a wholesale open access network. And there are, of course, lots of inquiries into data prices and so on. And the idea is that developing countries can in fact be able to catch up with developed countries in respect of mobile broadband in respect to broadband penetration by using mobile services. So in fact, the World Bank talks about actually that developing countries can leapfrog developed countries by skipping rolling out fixed lines. And indeed, there is a lot of research about the contributions that mobile can make, including by Jenny Acker in 2010 in terms of reducing price dispersion, by increasing employment, a paper by Hjort and Poulsen. But there's a problem because mobile, at least historically, there's maybe more debates about it today, but mobile has physical usage limitations. So very often there are caps measured in gigabytes that are imposed by mobile operators, and usage prices are very high as well compared to fixed broadband. Okay, so this is because mobile data is transmitted using very limited radio frequency spectrum. And so there's a question really as to whether mobile can in fact replace fixed lines. And South Africa is or whether indeed mobile and fixed are in fact complementary. And South Africa is a very interesting place to study this because fixed lines were only rolled out largely in whites-only neighborhoods during apartheid. Since then, there have been more fixed lines being rolled out, including more recently, and that's partly as a result of several subsea cables landing, and there's also been deregulation. So there's actually very little research, economic research that is, on fixed to mobile substitution in developing countries, and particularly in African countries where mobile services actually dominate. And previous research also focuses largely on voice and often aggregate data sets. We use a discrete-choice model to study voice and data services using the All Media Product Survey, which is a rolling survey of about 25,000 consumers per year over a period of about 6 years between 2009 and 2014. So it's about 134,000 consumers. And we use our results in our model to be able to try and think about how we could bridge the digital divide. So as I was saying, there are market inquiries by the Competition Authority, by ICASA, and so there are these questions as to how important is mobile pricing, for instance, which is what we seek to answer in this. And our paper also helps to contribute to this really important question, this digital divide between rich and poor countries, but also within countries and between different segments of society. And this is particularly important in countries like South Africa, where inequality is incredibly high, and there's certainly inequality in internet access. So just to give you a bit of a feeling for where South Africa sits in the world, and just to start to explore this question of the digital divide. So on the left-hand axis here, we have fixed telephones per 100 people. And on the right-hand side, we have mobile telephones per 100 people. And then these colors are more or less income. So at the bottom left here, these little pink countries are low-income countries. And then there's lower middle income countries, these kind of green ones, upper middle income countries, these pink ones, and then high income countries are these blue ones. And South Africa is actually way down here in the bottom right. So we've got very high levels of mobile cellular penetration, but very low levels of fixed telephone penetration, at least compared to upper income and upper middle income countries over here. And just to get into this idea of this digital divide in South Africa, there's a very, very big problem. So these are data from Statistics South Africa captured over the same period as the data we study using the All Media Product Survey. But the data look very similar today. So, or likely look very similar today. So in fact, in respect of race, for instance, of course, what we see is that a significantly greater proportion, the blue proportion, a significantly greater proportion of white households have internet connections at home compared to black households, for example. And this hasn't really changed so much over time, as you can see, between 2009 and 2014. Similarly, there's a digital divide between rural and urban. So, of course, in urban areas, a significantly greater proportion of households have internet access. Similarly, in respect of income, households earning between 10 and 20,000 Rand or more per month are significantly more likely to have internet access at home. It's also there's also a divide between those who are employed and those who are not. And of course, this is relevant for our current COVID-19 situation. So a significantly greater proportion of people who are employed have internet access at home. Okay, and there's a question as to how people could become employed if they don't have an internet access at home, at least in the current pandemic. So let's also have a look at the proportion of households that have fixed and mobile services. And again, what we see is an enormous digital divide. So there's a significantly greater proportion of white households, for instance, that have fixed lines compared to black households. Of course, this looks a little bit better when you look at mobile broadband services. So a significantly higher proportion of black households have a mobile broadband service, but there's still an enormous gap there. Whereas a very high proportion of white households have mobile broadband services. Similarly, there's a big digital divide when you look at geography, income, and again, the economically active population. So it turns out that, just to give you a bit of just to foreshadow our results a little bit, so it turns out that computers and internet access at work or at school really matter. So our results suggest that the way that we could increase broadband penetration in South Africa is partly, at least, by expanding internet access at workplaces and at schools, and by expanding access to the devices that are used to access the internet, including computers. And this corroborates consumer survey evidence that shows that actually the high cost of equipment is one of the main reasons that people don't connect. So this is this separate survey evidence by Statistics South Africa and the general household surveys that show this, and indeed by Research ICT Africa that also show this. It's also consistent with a very good paper by Bjorkegren in 2018, where he shows how the costs of handsets in Rwanda have a much greater impact actually on consumer surplus than usage prices for mobile services. Okay, so just to explain a little bit where our paper fits into the literature. So there are many papers that study fixed and mobile voice substitution using aggregate data. There are some household level studies that focus on voice, but not the internet. And then there is a paper by Cardona that finds that fixed and mobile data are substitutes using individual level data. But actually a big problem with much of this literature is allowing fixed and mobile services to be substitutes or indeed complementary. So many papers use an economic framework and an analytical framework that essentially assumes some degree of substitutability, when in fact it may be the case that we might derive greater utility indeed from using fixed and mobile services, and not simply be using these two services as substitutes. And again, there are some papers that allow fixed and mobile to be substitutes or complements. And we contribute to this literature by assessing this question in a developing country where mobile prevails. We also show what may expand internet penetration. So just to explain a little bit about our industry, so we've got much greater mobile coverage than we have fixed line coverage. So these maps roughly show the approximate locations of cell phone towers in South Africa compared to Telkom's fixed line exchanges. So of course, right. So we have significantly greater mobile coverage, and we also over this entire period, we actually we consider that there is internet availability to 100% of the population over the entire period between 2009 and 2014. And indeed, MTN and Vodacom's 3G and 4G coverage was expanding significantly over this period. And so we think this is a reasonable assumption. Now, we don't know exactly who has fixed line coverage and who does not. So the way that we infer this is from a whole range of demographic characteristics for households. So if the household needs all of these different elements in order to have fixed line coverage. They need to have electricity, a toilet, that dwelling needs to be formal, it needs to be a house or a flat, there needs to be a water connection, and there needs to be indoor plumbing, there needs to be a sink inside the house. So a built-in sink inside the house. And that's how we infer fixed line coverage. We also assume that no Black households in rural areas have fixed line coverage over this period, because that reflects the character and the nature of fixed line rollouts during and after apartheid. Okay, so let's have a little. So this is starting to explore a little bit our data sets, and this also starts to predict some of our main results. So first of all, it turns out that among the population that has a computer, 48% of households that have a computer also have a fixed line, but only 11% have fixed and mobile voice and data services. Again, there's just to illustrate this digital divide again. So within our data set, only 8% of Black people in our survey, in our all media product survey, have a fixed line at home, whereas half of white households have a fixed line at home. And there's similar disparities between choices of fixed and mobile voice and data services. And then the uptake among language groups is also similar to income. So among English-speaking households, uptake of fixed and mobile voice and data services, uptake of fixed lines is much higher, whereas this is much lower amongst Zulu, Xhosa, and Sotho-speaking households. In fact, we group languages together, and we can show you how we do that in the paper if anybody's interested in that. And it also turns out that actually older people are much more likely than younger people to take up a fixed line, which perhaps also makes sense. And people taking up fixed and mobile voice and data are a greater proportion of the self-employed than the not self-employed are likely to take this up. So again, this starts to predict some of our results that you'll see in just a minute. Uptake of fixed services is much higher in towns as cities, as we would expect. And it's also much higher among people who own their homes. Uptake of mobile services is a lot higher among households that have more than one cell phone. And uptake of fixed and mobile voice services is higher among households that have household members that also have a work telephone. And among people that use fixed mobile voice and data services are also much more likely to be taken up among households that have a gaming console. And I'll explain the role of the gaming console in our analysis in a bit. So we obtain prices from Terrifica, Research ICT Africa, and from the Internet Archive. So I had to go back and dig through a whole range of sources to gather up prices for mobile voice, for mobile data, and for fixed line broadband. And we assigned these different prices into different tariff profiles. So we had a prepaid tariff profile, postpaid high, medium, and low profiles. And then similarly, we had 3 mobile data price categories. We had high, medium, and low usage profiles. And then fixed line broadband, over this period, of course, Telkom was the main provider of fixed line broadband in South Africa. And Telkom assigned people into 3 different profiles, typically with their broadband packages over that period, and again, into low, medium, and high usage. Okay, and we chose the lowest price if there was more than one available per category. Okay, so and now let's just talk a little bit about our choice sets. So in our modeling setup, what we allowed consumers to choose between. So we allowed them to choose no fixed line. So we allowed them to choose standalone voice, and then we allowed them to choose fixed voice and data services. Okay, so there are 3 fixed line voice alternatives in our choice sets, in our setup. Then in terms of mobile services, again, we allowed people to choose no mobile service or standalone voice, or voice and mobile broadband services. So in 2009 and 2010, so pretty much before Telkom Mobile's entry, we had 3 mobile networks to choose from and 21 choices overall, because remember, you could choose a mobile network and you could choose between a voice service or a voice and a data service. And in 2011 to 2014, there were 4 mobile networks and 27 choices overall that consumers could choose in our model setup. Okay, so let's just have a look at what the data looks like for instance, for 2014. So in the bottom right here, we have about 25,000 observations. As I said, AMPS has about 25,000, surveys about 25,000 people every year over this period. And of those, about 2,500 didn't choose any mobile services, and about 19,000 didn't choose any fixed line services. And then there are, in the bottom right-hand corner here, there are the people that chose both fixed voice and data services, and they chose mobile voice and data services. And for instance, the people that did this chose Cell C. There were 358 people that did this, that chose this from the Cell C network, 739 from MTN, and etc. So this is what our data looks like for every year. Okay, and just breaking up the previous slide by years, more or less. So what we've got, if you just focus on the numbers in red, so we've got people that chose no mobile voice service. That fell, in fact, from about almost 6,000 people to only 2,500 people between 2009 and 2014. So of course we've got greater uptake of mobile services over this period, and we also have people. We have an increase in the proportion of people overall who are choosing mobile voice and data over time, from about 2,000 in 2009 to increasing to about 13,000 in 2014. So we've got much bigger uptake of consumer voice and data services over this period in our data. Okay, so just to go over our model just to go over the specifics for a minute or two. What we have is a utility function, and we specify the individual's utility from fixed services, for instance, as based on a number of characteristics X, such as age, gender, etc., plus the impact of price. So of course that enters negatively. The higher the price, the less utility that the person gets from a fixed line. And then we also specify utility for choosing a mobile service, and again that's related to a whole lot of individual characteristics X. And then the price of mobile voice and the price of mobile data. So these 2 prices are chosen separately in South Africa. You choose a mobile voice package, and then you buy mobile data bundles. Okay, so these are our utility functions, and then we allow utility to vary if you buy if you buy different bundles. So you could choose no fixed and no mobile in this first bundle. In the second bundle here, you could choose a fixed line, but no mobile. And in the third, you could choose a mobile service, but no fixed line. And then in the fourth, and this is what we're really interested in, is you get some utility from having a fixed line service. You get some utility from having a mobile service. And then there's some amount gamma, this upside down L here is gamma. And what we're trying to understand is whether gamma is positive or negative or equal to 0. So we're trying to understand whether when you buy a fixed and mobile service together, whether you obtain additional utility, or whether you obtain, if you obtain additional utility, of course, then the two services are complementary. If you obtain disutility, if there's negative utility, if gamma is negative when you buy the two together, then we would say the two products are substitutes. And if it's 0, then we would say the demand for the two services is independent. So this is our variable of our parameter of interest here, this gamma. Okay, so and we allow gamma to depend on consumer characteristics, and so this is quite interesting, and we'll show you some results on this front. A big problem with identifying true substitutability or complementarity is in fact correlations in preferences. So it might just be, for example, that people who are very tech savvy would just buy a fixed line and a mobile service because they're just inherently very tech savvy, and so their preferences are correlated, but they don't actually obtain any additional utility from buying the two services together. They just, their preferences happen to be correlated. And so, and similarly for voice services. And what we're trying to understand, so what we need to be able to do is to separate out true substitutability and complementarity from this correlation in preferences problem. And in order to be able to do that, we use a fixed voice shifter, which is having a telephone at work, and we use a fixed data shifter, which is having a gaming console. And the rationale for doing that is that having a telephone at work makes having a telephone at home much more valuable, because calls between fixed lines in South Africa are close to free, or at least you can buy very, very big bundles that make this very, very valuable. And so we think that having a telephone at work shifts the utility for having a fixed voice service without affecting the utility for having a mobile voice service. And similarly, having a gaming console over this period really required a fixed line to be able to benefit from in order to be able to benefit from low latency services too. So gamers like low latency. And so again, you had to have a fixed line for this. And so having a gaming console shifted out the utility of fixed data services without shifting mobile data. And so that's how we're able to identify the true substitutability or complementarity between fixed and mobile, rather than simply correlations and preferences. Okay, and the way that we do this is that we assume that we use this extreme value distribution in a logit model. So we assume that the probability that the individual chooses a bundle is the exponent of the utility that the person obtains from that bundle, divided by 1 plus the sum of the utility from all bundles. And we estimate this using log likelihood. Okay, so now getting into our results. First of all, what we do is, because there may be something that is shifting fixed voice, there may be something that's shifting the prices of a service and choices of the service at the same time, such as something like quality. We want to be able to make sure that we are identifying our price coefficient correctly. And the way that we do this is that we use a control function approach. So first what we do is, so we don't just simply regress prices on choices. We first run a regression. We first run a regression of prices on costs. So in respect of voice services, that's termination costs. And then we run the residuals, and then we use those residuals in our multinomial choice model in order to identify our price coefficients. And when we regress prices on termination costs, we indeed find this positive relationship that makes a lot of sense. And that we find in the literature, the various papers that show that as termination rates fall, so retail prices fall. So that makes sense. And then in respect of data services, what we do is we use the number of sites, because the number of sites affect data costs, but they don't vary so much with demand. So as we know, it can take several years to obtain permission to build a new mobile site. So mobile sites don't really vary with mobile demand too much. And so first we regress prices of our mobile data services on the number of sites in order to extract these residuals that we then use in our multinomial logit regression. Okay. And so these are our results. And what we find is that, so remember, we're regressing a whole lot of factors on the choice of all of those different services that I showed in the beginning. So, and what we find is that prices are negatively related with choices, which makes sense. So the higher the price, the less likely you're going to choose a service. It's positively related with our residuals. Remember, we use our control function to obtain residuals, and what we find is that, in fact, is that you're more likely to choose a service if the quality of that voice service is higher. So they're positively related. Similarly, with data services. And we also find that our fixed shifters work quite well. So having a work telephone and having a console shifts the utility from having a fixed voice or fixed data service positively, which also makes sense. On average, we find, in fact, that fixed and mobile voice services, so these two columns on the right here are our gammas, our indicator of substitutability versus complementarity. We find on average that fixed and mobile voice services are, in fact, complementary, which is quite interesting. But we find on average that fixed and mobile voice and data services are substitutes. So on average, we find fixed and mobile to be substitutable. However, what is interesting is when we start to interact the gamma with having a computer, having internet at work or school, in fact, that more than outweighs that substitutability. So our having a computer makes fixed and mobile voice and data services less substitutable. Having an internet connection at work or school makes having a fixed or mobile voice and data service less substitutable. This is how we start to show the kinds of factors that can help to expand broadband coverage in South Africa. And then so we find that actually among younger people, in fact, they're more likely to see fixed and mobile services as substitutes. Older people are much more likely to choose a fixed line in the first place, which also makes sense. Maybe older people are spending more time at home, more likely to take advantage of the very high numbers of calls you can make on fixed lines. People that rent their home are much less likely to choose a fixed line. So that also makes sense. So renters have less of a commitment to the household. So they don't know whether they're going to be there in a year's time. So they might not go through the time and trouble of having a fixed line installed. Being self-employed actually makes having a fixed line more likely. And both having a job and being self-employed makes fixed and mobile voice and data services less likely to be substitutes. Again, sort of, which is very important for our results. So of course, South Africa has extremely high unemployment levels. And so actually, when employment grows, we might start to see these fixed and mobile becoming less substitutable. And then finally, low income consumers are more likely to see the two services as substitutes. And high income consumers are more likely to choose a fixed line overall. Okay, and then having a cell phone at home, having more than one cell phone at home is more likely to make fixed and mobile voice and data services less substitutable, and that's again partly likely because of the fact that, and similarly for just fixed and mobile voice services, less more complementary, and that's because of the fact that because you can make many more calls from a fixed line. Okay, and so now we just had a look at what proportion of consumers, or what proportion of our different categories of people view fixed and mobile as substitutes or complements, and what we find is there's actually a positive coefficient among about 15% of consumers that have a computer at home. And among people who have internet at work or school, about 27% see fixed and mobile voice and data services as actually complementary. Among higher income consumers, of course, we see these services as being more complementary. So as people get computers, as they get more internet at work and school, as they have higher incomes, so these services are less likely to be substitutes. Okay, then what we did is we tried to say, well, how do we start to think about bridging this digital divide, and how what are the best kinds of interventions, having in the back of our minds, of course, that a lot of developing countries are focused, of course, on mobile. So what we first did is we said, okay, well, if we were to drop the price of mobile voice services, so you might have seen, for instance, that there's a lot of emphasis out there by the Competition Commission. They argued very strongly to bring down mobile voice services. So, and what we find, in fact, is that if you reduce mobile voice services by 10%, in fact, the total mobile penetration, that's the number right at the bottom here, actually only really increases by about 2.9 percentage points. So if what we're trying to achieve is sort of bridge this digital divide, expand access to services, actually we don't really see much effect of that from at least a 10% reduction in mobile services. But if we were to expand fixed line coverage to 100%, now some of you might be thinking, sure, that's great, but how is that really realistic in South Africa, where there were only 5.5 million fixed lines back in 2002, so maximum 5.5 million fixed lines, and there are 15 million households. So is that realistic? And I mean, I would say that you could go and have a look at what, for instance, Vumatel is doing in Mitchell's Plain, and what they're planning in Alexandra, quite low income areas, or middle income areas at least, but certainly much lower income areas than where you see fixed lines today. And they're rolling out fixed lines at relatively low prices in those areas. So if you were to say expand fixed line coverage, what we do is we sort of say, well, okay, among for example very low income consumers, so people earning less than 3,000 rands a month, if you would expand fixed line coverage, we would see fixed line broadband penetration growing from about 11.5% to about 15.9%. So you'd say, well, that's not a massive gain, right? That's sort of 3.8 or so odd percent, and yeah, so maybe not such a massive gain. But if you were to what our results do, and what the power of our model is all about, is that, and what it shows is that if you were to also provide all the households with computers, actually you would go from 12%, 11.7% fixed line broadband penetration to 23.2%. So you would double it. So that just shows you the power of, okay, A, rolling out fixed line coverage, but B, giving people the ability to use the service, the equipment to use internet. And then similarly, if you were to then add on, not only give them a computer, but also make sure that they had an internet connection at work or at school, then penetration at home would increase to 28%. And of course, high income consumers, of course, also benefit a lot. But the gap closes. That digital divide closes, albeit slowly, but it does close as you roll out computers and as you roll out internet at workplaces and at schools. And of course, the digital divide closes not only between income groups, but of course between race groups, which is also a very, very important issue in South Africa. So overall, expanding fixed line coverage does not do very much initially. It increases broadband penetration, overall fixed line broadband penetration, from about 22% to about 24%. But once you start to add computers and add internet at schools, then you get to about 37% broadband penetration. And that's much closer to what we see in developed countries, or at least certainly among other upper middle income countries in terms of penetration. Okay, and whereas the impact, in fact, of rolling out computers or rolling out internet at workplaces and schools doesn't impact mobile broadband as much. It does, of course, expand mobile broadband as well, but it doesn't expand mobile broadband very, very much, and it just sort of emphasizes the important role that fixed line broadband still has to play. And so on this graph, I just wanted to show how, in fact, our results corroborate what we see using sort of quite basic descriptive statistics. When we look at data, for example, for the whole world collected by the International Telecommunications Union, what we see is that the percentage of households with internet at home grows is positively related with the percentage of households with a computer. So this idea that sort of that the equipment, the tools needed to use the internet are sort of at least positively related with internet access at home is consistent with our results. Okay, so just in summary now, just to explain, we use a discrete choice model of consumer choices of fixed and mobile voice services. We use consumer level data that allows us to assess fixed and mobile substitutability at the level of the individual. And we find actually that at high levels of income, greater employment, and particularly self-employment, with greater levels of internet penetration at workplaces and at schools, and with access to computers, actually all of this contributes to greater broadband penetration. So actually expanding fixed lines, including internet at work and schools, and access to computers has a similar effect to reducing mobile data prices by 10%. And so in the end, I would say that focusing exclusively on mobile services in developing countries may not be correct. So the mobile revolution in Africa may be somewhat oversold. And just in case anybody, just to put everybody in the picture as to where South Africa is at, for instance, in respect of internet penetration at schools, 80% of public schools do not have a classroom where students can access the internet. That's in 2019, according to the Education Department, according to the National Education Infrastructure data sets. So in fact, there's a big opportunity, including through SA Connect, in fact, to be able to bring about internet penetration, not just in schools, but what we show is that has an impact on homes as well. And one of the mechanisms that's been thought of, in fact, by Liu et al. is that people figure out applications for the internet at workplaces and at schools. And then they're able to see why they would want to use the internet, and so then they get an internet connection at home, and so that's one of the reasons, that's one of the mechanisms that could be sort of explaining our results. Okay, but thank you very much. That's the substance of today's presentation.
Thank you very much, Ryan, for the presentation. And of course, I could have some questions, but I know the paper, so maybe first, if there are any other questions from the audience. I saw there was one question on chat. Did you run a counterfactual in the absence of fixed line universal service?
A counterfactual of what? I mean, that is the baseline in our results. So the baseline is in fact the status quo, where there is no universal fixed lines. So in fact, right. So that's our baseline.
So
that's the first column.
So the
on the left,
10% price is as if the observed fixed line penetration, but then
exactly.
the next three columns are assuming 100% fixed line coverage.
That's right. That's exactly right.
Are there any other questions? Please feel free to ask. Okay, I know this paper, but I can ask questions still. So I find the counterfactuals maybe a bit disturbing in a way that, okay, there is a model and it's nice to make some use of this model. What I find disturbing is that, so assuming 100% fixed line coverage, which clearly is very expensive to implement or even beyond any possibility, there's still very small take up of fixed line, which means that actually, or suggests that actually people prefer mobile broadband rather than fixed line. So this huge investment potentially in fixed broadband coverage would have very little chances of paying off, because as this suggests, take up doesn't increase. And again, like, okay, I know that the technicalities, so this coverage is being implemented by enabling people to have access to fixed line, while in reality, they don't have access to fixed line. So it's like giving them the choice to have fixed line. So here is like spreading a fixed line coverage for the whole population actually doesn't bring much in terms of take up. I don't know whether you have any comment on this.
Right. So I mean, so that's a fair point, and the cost would be substantial. There are three things to note on that. First of all, that's true. So we see fixed line broadband penetration expanding from about 22% to about 24% by this huge expense, as you say, of rolling out fixed line coverage everywhere, which is only 2 percentage points. So what's the point? So people are still using mobile, right? But I think what's really interesting about our paper is that once you, if you were to also make sure that everybody had a computer at home, so had the ability to actually use that fixed line data service, that broadband service, then penetration actually expands dramatically to about 31%. If you were to in addition make sure that all schools and workplaces, as should be the case, or as we see in many parts of the world, also have internet access. And the expense of that is not very great. Then we start to see fixed line broadband growing all the way to about 37%. And now you might say, well, 37%, who cares? But actually what we see in the rest of the world, the sort of the maximum broadband penetration that you see in the other parts of the world, fixed line broadband penetration in upper income countries, in the wealthiest countries, the top is about 60%. The very, very maximum, according to the World Bank. And so reaching about almost 40% fixed line broadband coverage would put us in the sort of top third of this graph, which is about what you want. That's about right, is what I'm trying to say. That's about what could be achieved. Yep. So I would have those comments. I would have those comments in response to that.
Okay. I have another question on this, but maybe first there are two more questions on the chat. Can you see?
Right. Sorry. Actually, let me try.
So this question from Evan Sutherland. You report somewhat limited increase in uptake to a 10% price cut, but much bigger price cuts could be envisaged. What would be the effect of, say, 20 or 40% price reduction?
Right. So that's definitely worth checking. We haven't actually checked. I think overall what this kind of suggests, though, is that people aren't so price sensitive. So in fact, let me just get to our results. So I mean, so in respect of mobile data services, these coefficients kind of tend to indicate that people aren't very price sensitive, aren't so sensitive to the prices of data services. Okay, so this was between 2009 and 2014, so this may have changed by now, but I'm actually not sure how much additional price cutting would actually get to. I mean, so I think what the again what the sort of what our results sort of suggest, and again this is in line with what we see just from direct survey evidence, is that some of the barriers to the internet is not just access to is not just the price of the usage price of the service, but it's also the equipment to be able to use it. And I think that's quite an interesting sort of outcome of our research. And then, sorry, so that I for some reason can't see the chat.
Okay, so there's another question from Charlie. What I was asking was where the focus on internet access at work, school, still has the greatest impact in the absence of fixed line rollout.
Right. So even in the absence of fixed line rollout, what impact would greater internet at work and school have? That's also a good question. That is something we can maybe explore.
However, I have actually a comment on this, and that's something I wanted to mention, which is that it's not possible really to assess the impact of rollout of internet at school if you don't consider in the model that there's access to fixed line, right? Because the way the model is set up is that you need to have fixed line access, and then you decide whether you take it up or not. But if you consider that there's rollout of internet at schools and you don't have fixed line access, then you cannot really model how this impacts take up, because you assume that people cannot have fixed line. So it kind of, I don't know. So one thing is rollout, which is investment by firms, and the other one is when there's rollout already, what impacts take up of it, right? So in my view, it's not possible to model impact of schools rollout at schools on fixed line take up without assuming that there's coverage. I don't know whether you have comment on this.
Right. I mean, it's something we can check maybe. I am not 100% sure. Right. Okay. Yeah. Right. Would we? I think I'm not sure. We'd have to check. I'd have to get back to you.
We still have time for questions, of course. So feel free just to speak up if you want to ask something, unless you have problems with microphones or so. Okay, I can ask one more question. So one of your conclusions is that the role of mobile broadband is overstated based on the results, but is it really overstated? So related to what I asked before, we do not see that much take up of fixed line broadband, even with full coverage, which means that most people still like using mobile broadband. So in that sense, is it really overstated? Like, it seems to me that people really like using mobile broadband.
Right. I mean, well, yeah. I mean, that's true. So in our sample here, almost 2/3 of people use mobile broadband, whereas only 20%, I guess, use fixed broadband. So it's So you're right. So mobile broadband is extremely widely used. I would just say though that its role may still be overstated in the sense that that it's at least over this period, it gave you a very different kind of service. I mean, while we treat everybody who said that they use a mobile data service as having mobile broadband, in fact, what they could buy was a gigabyte or 5 gigabytes or 10 gigabytes. whereas average usage on fixed lines is closer to 200 or 300 gigabytes. And so it's not actually clear that the two services are kind of comparable in the first place. The one sort of enables unlimited usage. The other provides internet access, but isn't necessarily the equivalent thing. And at the margin, there may be a lot of people who just don't use that much data and who don't really want to and have no application for it. And for them, of course, and there might be lots of people like that. But again, what I would say is that actually as people become employed and as incomes grow, so in fact we see the two services as being less substitutable. In fact, and so while this is kind of a snapshot of South Africa at the moment, as we develop, we might see those patterns of complementarity and substitution changing quite a bit. So yes, it's true that most people use mobile, of course, but that may change quite significantly in the future as we develop.
All right. There's also some more comments more than questions. So about counting fixed lines per 100 of population, where the composition of households varies by country, and there might be some overall understatement. But I guess that's maybe not so relevant here, right? Or is it? The way.
Yeah, I mean, this is just sort of. Do you mean this? This initial kind of. Sorry.
In the modeling, it's based on answer by individuals, right? Because
right.
Individual, if they have access or not, but for the statistics, maybe indeed.
Right. So here you mean this descriptive type of information, that these are comparing different household sizes. That's true. I'm not sure where the comment is or what.
Right. Okay. So this might be true indeed. Are there any other questions?
I'm sorry, I don't know why I can't see the chat. I think it's because I'm sharing the screen.
If there are no other questions, then I guess we can finish, even though we have still 8 minutes left. Right. Okay, there are no questions. So I would like to thank again Ryan for his presentation. And as said, this paper is part of the thesis and is being in the process of submission for publication. If anybody from the audience would like to present his or her work at the seminar, we welcome a lot any submissions. So there are free slots in the coming weeks. Otherwise, please check out the website of ERSA for presentations in the field of industrial organization, digital economics, as well as in other fields. I think next week we'll have interesting presentation by Daron Asemoglu on COVID. So please follow the website and sign up for emails with that respect. Thank you everyone for participating, and I hope to see you next time at the next seminar. Thanks, Ryan.
Thank you. Sorry, I see